One day, the reason behind our existence, the sun will swell up enormously. It will swallow Mercury, Venus, and probably even our home, the Earth. Sounds terrifying, right? This apocalyptic event is bound to occur on Sun's deathbed. Yes, you heard that correctly. Even the sun is going to die someday. But have you ever wondered how it would happen? What will the death of our beloved star look like? And most importantly, will the sun become a black hole? To answer all these questions, first let me tell you what's happening there. From the Earth, the sun does not appear to be an active celestial body, but up close, it is the most turbulent place in the entire solar system. Every second, 4.2 billion kilograms of the sun's mass is converted into energy. The sun is so big that 1.3 million Earths can fit inside it. OMG, right? So you may be wondering that if the sun is so big, what keeps it stable? I mean, why doesn't the sun collapse under its gravity? A star's life is a constant struggle between two forces. On one side, gravity is trying to crush it, but this collapse is halted by the energy from the nuclear fusion reaction in the core. Inside the solar core, hydrogen is being converted into helium. This nuclear reaction at roughly 15 million kelvins has been going on for 4.6 billion years, and it will continue for another 5 billion years or so. But one day, the core will exhaust its reservoir of hydrogen. All the hydrogen will be converted into helium, and this is where the happy days of the sun are over. Why is that? Remember I told you there's a balance between the two opposite forces? That balance is now disrupted because the core is shut down and no fusion is taking place. The following fusion reaction, helium to carbon, requires a temperature of 100 million Kelvin, which simply isn't there. Phew, pretty mind-boggling stuff, isn't it? While all this is going on inside, the sun has swollen and become a red giant star. It has already swallowed Mercury and Venus. This expansion will roast our planet, if not consume it. You must be thinking that the sun won't survive this gravitational collapse. But there's a twist in the story. The gravitational collapse proves to be a blessing in disguise. The collapse itself raises the core temperature, and it becomes hot enough to fuse helium into carbon. However, there's a price to pay. The core does not ignite casually. Instead, it's an explosive event known as the helium flash that releases so much energy that almost 6% of the core immediately converts into carbon. The two opposing forces are perfectly balanced again, but the supply of helium is limited. One day, all the helium converts into carbon and the core shuts down. No, unlike last time, it did not take 10 billion years to fuse helium into carbon. It was just a matter of a few million years. So what's the problem now? After a short period, the sun will start another reaction to fuse carbon into subsequent elements. Isn't it? The answer is no. The temperature required for the next fusion reaction is a whopping 500 million kelvins. The sun isn't big enough to host a full-scale carbon fusion, so the core will never ignite again, and it will give up its fight against the gravitational collapse. Now, is there anyone who could save our dying sun from a complete collapse? Is there any hope left? The answer is yes. This time, one of the tiniest particles in nature, the electrons, will come to the rescue. I know most of you are not quantum physicists, so let me put this in simple language. Electrons are like two colleagues who sincerely hate each other. Just like no two of them can sit peacefully in one office room. Similarly, two electrons cannot occupy the same quantum state. Therefore, any force that tries to put them together will have to face resistance. And I tell you, this opposing force isn't weak. So, how is it going to save our dying star? Well, in the absence of the nuclear fusion reaction, gravity has gained the upper hand. It starts crushing the star and forces all the electrons to occupy the available energy states. Since the electrons hate each other, they disagree with sharing an energy state, and eventually they take a stand against gravity and halt the collapse. Over the years, the sun will lose its outer layers and become a white dwarf star. It isn't mass enough to become a black hole. After that, this white dwarf star will radiate all its energy, becoming a black dwarf, entirely invisible to the equivalent of the human eye. That's how the sun will eventually end its life. But don't worry. If our civilization is wise enough to not kill each other with nuclear weapons and keep progressing in science and technology, who knows, we might become interstellar species by then. Do share this video with your friends and in the comments section below. Let us know the topic of the next episode of the Ever Wondered series.